Yeah, so thanks everyone. Uh, let's we have to begin with the session. Hope my screen is visible. Unfortunately, in the meantime, I've failed to log in again, so that's why. Yeah, but we can continue the sessions and we can move ahead. So, a very good evening to each and everyone present in the sessions or in the workshop organized by the MSME. Uh, the workshop topic is generative AI and the agentic AI. Uh, Currently, if you belongs to any of the respective branch, whether it's a healthcare, whether it's a manufacturing, whether it's a sales, or whether it's a IT, the AI revolution is super important. And as a tech person or as a non-tech person, whether you belongs to a technical field or whether you belongs to the non-technical fields like the educations, or we can say that in the sales field or in of the manufacturing department or productions, healthcare, medicals, irrespective of these sectors, the AI is everywhere. It's not about only in terms of mobile phones or in terms of your day-to-day uh, gadgets, electronic gadgets, like for the example of smartwatch, smart TV, smart fridge, smart mobile phones, and everything. When we move to perform any of the simplest tasks, just like writing a simple email to anyone or watching videos on YouTube or reading any specific part, AI is everywhere. So the workshop is a comprehensive kind of a stuff here, whether we are going to see some of the generative AI capabilities. Also, we are moving towards to see like how the generative AI is giving the birth to these agents and how this agentic AI is changing the workflow, changing the environment just by clicking on one line of a commands. For example, if we are planning to go to the schools and trying to take the admissions of the students, I think there are plenty of the windows might be there where we have to visit. There is an inquiry window, there might be the brochure window, there might be the fees department window. So there might be the plenty of windows would be there, and we have to visit every window. Similarly, kind of a things, if we are planning to perform any of the specific task with just one line of the instructions, our agents will perform the entire workflow. So this workshop, generative AI and agentic AI, if you might seen on my screen, there is written it's as hands-on immersion. So yeah, as a tech person, I always believe the hands-on activity instead of the theoretical concepts. So obviously we will go ahead with some of the in-depth understanding of this generative AI, agentic AI, as well as this particular about how the LLMs are working and everything, so what embeddings and each and every parts. But yeah, with the hands-on activity, we will get more understanding, more in-depth idea about how actual the particular LLM is performing and how it's working based on the instructions. So that is something, the beauty of this workshops. My aim is always to deliver the entire workshop in such a way, if in my class, or if in this workshop there are 35 or 40 candidates should be there, so from candidate number 1 till the candidate number of last, whether 35 or 40, all should get the equal understanding. Also, one of the humble requests to each and everyone, if any particular specific things if you are not able to digest or understand, just give me the shout. Because if you will not ask, if you will not come up with your queries or concern, definitely it would be difficult to understand whether you people will get the exact idea or exact understanding or not. So that is my humble request to each of the participants. Myself, Dr. Masiuddin Khan, I just giving the small introductions here. Uh, from last more than a decades, I'm into the training and the development. Currently working with this Evidence LLC as a senior generative AI engineers, where I'm a Google certified, AWS certified, and the Azure certified machine learning engineer as well, in the terms of the associate as well as the professional as well. So these are my expertise areas of the machine learnings, agentic AI, generative AI. I will try to compensate this particular sessions in such a way so that you will get the real time examples and the ideas like how exactly this generative AI is working. So this is about myself. Now moving towards about our curriculums. So as already you people have this particular curriculum, so I will take few minutes to go through this curriculum here so that we will be on the same platforms. We are not going to miss any specific part. If I will go to this particular module one, like introductory part of the LLMs or generative AI, then we'll go to the prompt engineering part, and then we'll move to the embedding and the RAG about, or the vector database that we can called as the vector embeddings, and then we'll move to this retrieval augmented generation. So today and upcoming days like Sundays, we are going to cover this 1.1 till 1.4. That would be our target. And once that particular things will be done, then we will move ahead some of the frameworks, because the LLMs or the generative AI models or the agents, whatever things we are going to build up, obviously we always need a framework because we have to present something. So the framework is very, very important. We will go through with the LangChain, Llama Index, LangGraph, LangSmith, that kind of a stuff. We are going to understand like how exactly the things are happening. Then we'll see some of these advanced RAG. When I'm talking about the advanced RAG, there are two ways of RAGs. One is a traditional, and one is, we can say that about agentic RAG. So the advanced RAG, we can say that multi documentations based RAG, and the uh, traditionals, we are passing some of one type of a documents, and that is, we can say that would be the traditional kind of a things. And we also see some of these agentic concepts, like what do you mean by the agents, how the agents are working. There are plenty way, like the Google is just launching about the ADK, agent development kit, which is also the frameworks, and you can develop of open source, uh, I can say that, agents. And how the architecture and how the frameworks are working, how we can deploy on some of the cloud consoles, whether it's a AWS or whether it's a GCP. So that's some shorten also, we will see to it that in the third module. And then we'll finally move to this particular module 4 as the building and evaluating agents like multi-agent systems. Just I given one introduction about the college admissions. So with one commands, like if I will pass a commands, I'm looking some of the code. So in that particular periods, my sales agents or whoever the agents would become in a pictures. If I will ask about what are the policies. So in that time, the sales agent is going to be sidelined and the policy agent will come in the pictures. And if I will ask, share me the curriculum, so the curriculum agents will come in a pictures. If I will ask like, okay, go ahead and purchase this course, so that time again the sales agent will come, or admin agents, or we can say that account agents will come. And if I will ask like a refund, give me the refund, so again the admin department or admin agents will come and provide me the refund or entire refunds about this particular thing. So that is, we can call it as a multi-agent systems. Or we'll see some of the use cases which are real today or real time based, we can say that. We'll also see some of the agent memory, because right now whatever we are talking here, uh, to Sunday when we are going to meet between the 6 to 9 p.m, definitely it might happen in the 3 hours of conversations. Whatever we talk today or whatever we learn today, it might happen 60%, 70% you people might remember. But it might also happen like some people will remember 100% as well. That is also possible. It might happen some people will remember only 30%. So that kind of a possibilities we can see to the human being or human behaviors. But with the agents or agent memory or the state managements, for example, today I had a conversations with the agent, and 3 days later I'm or one day later or after few hours later again I'm going to connecting about the agents, and I will ask, do you remember my conversations? So we have to build some of the memory bank to the agents, because memory is super important when we are dealing with the real time problem statement. That time this kind of a memory bank super important. So that particular state managements or the memory bank we are going to see. uh, then we'll also see that evaluations and responsible, like we have to evaluate, because see, whenever we have to pass any specific task we have to evaluate like how much quality or how much the confidence score my agent is providing. That is also important. For example, if I pass any PDF and I want to extract those particular data from PDF, so at least I should get the understanding like how much percentage my agent evaluated. Is there anything, sir? Because we are going to check manually, that would be a difficult. So if we evaluate those particular things or performing some responsible AI for agents, that would be also good techniques we need to understand and we need to learn here. So that is the overall comprehensive things we are going to learn in 10 days sessions. In the meantime, it might happen the 30-hour session is going to be designed. It might happen some few hours might be increases. I'm not saying right now only, because the concept generative AI, agentic AI is little bit heavy. So some concept or some things might take few more times to understand or digest, because we have to move ahead for the hands-on activity as well. So definitely we will approach accordingly, but I will try to finish in the next in the 30 hours. But it might happen because the things might be difficult sometime as well. So that's all. Anyone have anything or any things in your minds related to this curriculums or this particular workshop uh, uh, modules or anything? You can definitely write a questions in a chat box as well. Also, I can say that you can stop me in between the session as well, and you can talk, but just by turn on your mic and just you can talk as well. I'm not giving any limitations here. This should be a two-way communications, guys. It should not like a trainer is going to explain a lot of things or always talking. It should be a two-way, because you people are also working professional just like me. So I always expect the same way or same way conversation we are going to discuss here. So that is the baseline I'm setting for each and everyone. We have to test in between the session or in between the hands-on activity as well. So let's we have to begin. And in the meantime, if anyone having any question, queries, so please you can.
Hello, sir. I have a
Yes.
question. My name is Arjun Chaudhary. I am from Kolkata, but currently I'm in the Netherlands doing my PhD. So I had a question, sir, because I'm also working on multi-agent systems, and I do not have IT or like any kind of programming experience. But I really wanted to know how do we like also like integrate the stakeholder feedbacks or like the stakeholder concerns into the multi-agent system. So even if you could also cover that when we are doing the multi-agent systems, that would be very helpful.
Sure, I will try it. I will try it. That particular things I will try to add in the multi-agents systems. I will try to
Definitely.
build that particular things.
Yeah, hi sir. This is Malikram from Hyderabad. Am I audible, sir?
Yeah, yeah, you're audible, sir.
So, what are the prerequisites required for this hands-on Python, like Python or any other open source?
Uh, you just require the Python understanding, Python line of a codes. You need understanding and some of the workflow of the machine learnings. Nothing else about. I can say that at least you have some basic understanding about like how the models are working, so LLMs are working. So that kind of a little bit understanding is required. And obviously whatever we are going to perform, some of the hands-on activity or the practical implementations, that definitely required a Python understanding as well, like the Python's libraries, TensorFlow, PyTorch, or the scikit-learns as well, and some of the transformers things as well.
So,
Because each of the things have the documentation, so with the help of that documentations, definitely you will get that understanding as well. But Python understanding is must.
okay, so my another question is, will this hands-on be on cloud, or do we need to install it
No,
on?
no, we are going to perform on the Colab Enterprise or the Colab Google Colab Notebook. So our main things, we are going to focus on the Colab. But if we are going to build some of the app or something like that in a development mindset way, just like Arjun has mentioned. So it might happen sometime, or we can use VS Code as well. But our majority of the things, like 80 to 90% task, I will try to cover in that Collab Enterprise only. It's not
Oh,
enterprise, Google Colab. That's an open source platforms that I will guide step by step how you can use it, or how you can create the API key from the Google or any of the things. So that I will cover that particular things in upcoming hours. I can say that.
okay. Thank you.
Yeah. So guys, in between, I might able not able to see. Might not able to see your chat, so don't mind guys, because I share my screen. So it might happen, but I keeping the small window, but it might happen sometime I am not able to see. So but I will check in 10 to 15 minutes after covering the topics. But don't worry about this particular things. So that is just things. Let's see how to kick off. So
Good evening, sir. I have a
yeah,
question.
yeah, please.
Yes, sir. This is Catherine, and I'm from Bangalore. I'm only just finished my first year of engineering.
Okay.
So, would I be able to cope up with whatever that goes on in the class by the end of these 10 sessions?
Can you just come again with your question, please?
Sir, I've only finished my first year of engineering. So,
Mm-hmm.
would I be able to cope up with what happens during these 10 sessions? Is what I'm
Yeah,
asking.
yeah, 100%, 100%. You will
Okay,
cop up.
all right. Thank you, sir.
Yeah, 100%. Those who are non-technical background, they can also cop up that particular thing. So not to worry about, guys. The curriculums and everything, or the delivery things I design in such a way there are not a lot of codings. There might be in today's sessions we are going to do some of the prompting part, and in the upcoming session and the RAG as well, I try to minimum codes in that particular part, not about the maximum coding, so that each and every will understand and digest about how this exactly things working. And I will try to explain each line of a code or each line of a workflow in such a way like how the things are working basically.
All right, sir. Thank you so much.
Yeah. So hope my screen is visible, guys.
Yes.
Yeah, thanks. So I'm coming to this, but first topic is the or the today's things which we are going to cover. I will try to cover this particular 1.1 till 1.2. That is my main agenda, to cover this particular quick introduction to generative AI and LLMs. Uh, so let's first try to understand about like this particular part. What is generative AI? So these are the two tasks which is our main target here. I'm not much believer in the PPT. I'm much believer in this hands-on activity. So because that reading everything will not get the best understanding the way we are going to perform. So that is my always motive, to give the maximum hands-on activity instead of presentation. You will get the presentation and every slides and a lot of materials as well related to this generative AI and agentic AI. But yeah, whatever the sessions we are going to cover, that is belongs to more towards the hands-on activity. So coming to this quick introductions to generative AI and this particular part. So what is a generative AI basically? Nowadays, I think uh, the childrens are also aware about what is a generative AI. But before the generative AI, I just want to come from traditional machine learning and the deep learning. That's just a short introductions I just want to give to all of you from where this particular part is coming. The traditional machine learnings having the capability of giving the predictions, or model is going to be trained on a specific data, and when we pass some of the inputs related to those data, my model is in a capable or positions to predict whether it's a fruit or apple or whether it's a mango, that kind of things we are getting. Later the innovations are moving ahead, and we enter into the world of deep learning, that is called as a neural networks. Basically, neural networks is something like to mimic the human brain, just like how the human brains are working. So we enter in that particular periods because the data is increases rapidly, or I can say that very fast for each of the field. I can say that it's not about related to only IT or related to only medical, in each of the department. So how we can understand the sentiment, how we can predict the image, or how we can classify the image, or how we can use those technology in the mobile phone for the face recognitions, for the finger concept, lot of things we are where we are going to uh, develop with the help of this deep learnings, or the how the our brains are thinking, and the way we have to build a machine so that machines can also adapt the same way, just like the human behaviors are there. So the deep learnings in a coming in a pictures, and there are two ways are going to develop. One was called as the computer visions, and the second one is called as the natural language processing. In the computer visions, where mostly we are belongs to image classifications, image recognitions, video processing, image processing, that kind of a scenario where we enter. But the natural language processing move towards about textual context, like based on the text or based on the email, whether the email is a spam or whether the email belongs to your ham, or predictions of the next word. For example, hi, my name is. So the when you have to write, or when you have to write any emails, you might getting some of the responses like thanks. Then by default you will getting the next word predictions like and regards or something like that when you type any particular email. So that belongs to something we can say that NLP part, natural language processing, just like how we are dealing with in day to day. But one was belongs to your computer visions, that belongs to the image processing, video processings. And from that, there are two things were developed. One is called as the LLM, and one was called as the LIM. LLM is belongs to your large language models, and LIM belongs to your large image models. Just like you might seen about the VO of the Google Gemini, VO models, which is capable to produce the videos or the images, or the Sora. You might seen about the OpenAI Sora, that is capable to produce some of the videos or also the images as well. There are plenty of models like Dali's as well, and there are some, not some, there are more related to the large language models. And language models are something like we can say that more commons or more useful in day-to-day's life. Just like in front of my screen, you might seem like Cloudy, ChatGPT, Dali, Devin. There is plenty of this thing. Like you might seen about here in the news, 1 week ago, the Kiwi K2 is launched, and he already beaten to the Grok 4, which is the latest model by the Elon Musk Grok. So he was already, and he is going to be contending along with the Cloudy. Cloudy is the most technical LLM models developed by the Anthropic. So that model is most capable models to develop a code. If you provide any commands or any instructions, that model is superb capable. But Kimi K2 is going to be competing with the Cloud. So plenty of the LLM models are going to be launched. but that LLM models belongs to your NLP. So that is the history I just highlighted about how the LLM is going to become, because till NLP, till computer visions, we are predicting. That is, we can say that we are that things are not belongs to generating. But after that, when the transformer comes in the picture, that we are going to see in the next hours of this particular sessions, uh, how it was work or how we got that particular things. So I will come to elaborate about what is the generative AI. So in a very simple layman way, I will try to introduce or give the introductions. So generative AI is basically, we can say that it's a type of AI or artificial intelligence that creates a new content. That means it generates text, images, audio, video, and more. Just like how human might write a poem, like you might seen about a lot of movies in that there are the lyrics, the story writers are there, they're writing the story by thinking about different songs, just like you might see in Ed Sheeran's latest songs about Sapphire. So that kind of things, we can say that the script writer is different, the singer is different, the lyricist person is little bit a different person. So just like how human might write a poem, paint a picture, something like that, or compose a music. Similarly, these models also capable to generate text, images, audio, video, and more. And it's called a generative because it generates, creates something instead of just analyzing or the predicting. This generative AI models are capable for both predictions as well as the generations. But your predictions model, those who are non-generative AI models, are only capable to predict based on the historical data. This generative AI models is also trained on the historical data on the billion of parameters. For example, those who have some of the experience, for example, or in schools, all might aware about like linear regressions. That is a simple concept I'm giving here. That is a simple concept I'm coming to elaborate. The linear regressions or simple line equation is y equal to mx plus c. And in y equal to mx plus c, if I want to calculate y value, so I need to the different value mx plus c is might be the intercept, m is might be the slope, x is might be the independent variable, y would be might be the dependent variable, that kind of a things. This is not a part of this particular, but I just want to show you like how the predictions are happening. For example, if I'm going to train my function or my model in such a way, like height versus weight or weight versus height. So if I'm going to train my models or limit a models, we can take a small children or small kid example. If you are going to show every day, this is A, this is B, this is C, this is D, this is E, this is F, alphabets only. It might happen day one, he will not train in such a way. Similarly, when you have to train multiple way times, your child or the kid might be trained in such a way. When you pass or when you show only B, he will definitely say like, yeah, it's a B. When you pass C and you will ask something like, after C, what will come? So he will say, after C, the D will come. Why? Because he is trained in such a way. Similarly, that your NLP, your image recognition models, your different machine learning, deep learning models are trained. Now, these generative AI models are little bit different. They are not like your traditional ML or deep learnings. They also train on a billion of parameters. When I'm talking about the billion of parameters that we are going to see in the upcoming, like in the next part about this particular things, because we are going to discuss something like uh, training of this particular LLM architectures. But let me finish about this particular first. So what generative AI can do, first of all, a generative AI can do when we have to give the input, like a prompt, like write a story about a dragon and robot. And what generative AI creates, it will create a full story. When you are give a prompt, a drawing of a cat, obviously your model is capable to a realistic or aesthetic version of that is going to be created. What your voice samples, it is capable, can generate you saying new script or something like that. A melody, a complete song based on it. A sample sketch of a house, a realistic looking 3D kind of a things it can develop. So in the real life examples, this is Gemini. You can see to it that just I open about this is 2.5 flash models. So you can see that two models. You can open a lot of models are there. Just like if you want to see the ChatGPT, that is the most common. So this is also something we can see to it that uh, ChatGPT. This is a generate text answer or something like that stories. Delay. If you can go ahead in the ChatGPT, this is upgraded. I'm using the free versions. You can see to it that Sora. If you click on the Sora, you can see that this is a video generation models. You will get it. And if you pass any describe anything, so definitely it will try to build up something like this. So this all the things are going to be available in the Sora. If you go ahead in the Gemini, you can see to it that video. If I will just write here and I will write create a video on uh, rain happening, or not rain, video about cat and mouse fight. So let's see, you can see that I taken about the video. So here this model is going to be generate a video. It might be a costly things about like, because as I am a Google partner organizations employee, so I'm getting that particular freedom, so I can build up this particular things. Or if you are a Google things or Google related things, so you will get this Gemini kind of a things free of cost as well. So I can use this pro or something like of this thing, so it might be take 1 or 2 minutes. And that capability we can see to these generative AI models as well. Also I just want to show you about something if you are going to develop something, or if you are going to prepare some stories, just like a full story of about a dragon and a robot, or any of this particular stuffs. So that is also, if you want to hear those particular things, so you can use with the audio things, and you can build up. So you can see to it that the audio video is generated. You can see to it that this is Google's super powerful, we can say that models, Vivo, uh, and behind that 2.5 Flash and 2.5 Pro models is built up. So it is capable. We can create that particular. You can add some of the photos, and you can give the prompt. Definitely, uh, this LLM, not this only Gemini, you can do for the Chat GPT as well. You can add photos and pass the command something. Definitely, you will get that particular things as well. So it's not about only you can use the Claude, you can use the Kimi, you can use the DeepSeek, you can use the Grow, you can use any of these particular models. So how does this basically a generative AI is trained on or work? How this particular things is basically working?
Hi, sir. Praise this side. I have a question actually.
Yeah, yeah, please.
So when we talk about generating content actually or generating content, So does RNN come in this generating content thing, or is it about like prediction?
Can you come again? Can RNN?
RNN is more about prediction, or it comes under generating content?
Okay. So your question is like RNN is more about prediction or generations, right?
Right.
Okay. So uh, recurrent neural networks, basically we can say that are particularly when I'm coming to like for the prediction and generation task related things. So I will give some of this idea like why RNNs are good for predictions and the generation. First of all, so RNN basically can learn temporal patterns from the past data, okay, and predict the next values in a sequence, like example the time series forecasting, next word predictions. And when we are coming to the generation part here about this, so RNNs can be trained to generate sequence like a text, music, or even code by predicting and sampling one token at a time. So that part obviously I'm going to cover in the next slide only when I'm moving toward to this particular slide. So RNN use cases in prediction and generations, when we are taking the domain of the NLP. So in NLP, it will work as the next word predictions, machine translation, chatbot reply generations. When we are moving to the domain time series, so stock price predictions, weather forecasting. When we are coming to the domain like music, so it generate melodies or the notes, something kind of a things. So RNNs are designed for sequence modelings and are great for both predictions and the generations, not only about the predictions or the generations, especially where context over a time matters. But for better results on complex sequences, LSTM, GRU, or transformer are generally preferred nowadays.
Got it, sir. Got it. Thank you, sir.
Yeah. Anyone having any more questions, you can definitely pause me in between the sessions. That would be not an issue, guys. Definitely, if any things you have not grabbing or not understanding, give a shout, please. That would be a good way of communications from each of the sides, I can say that. Okay, so I was
Yeah,
coming to,
sorry,
yeah.
I have one doubt. So when you say Gen AI, so already there are a lot of tools available. So what we will be doing, or what way will differentiate from the available tools?
I'm not getting available tools in such a way. Can you just elaborate a little bit?
Like the Gemini or ChatGPT
Uh-huh.
or DeepSeek. So already they are using the Gen AI, and what we will differentiate from those tools.
See, if you want, I can say that you have to see the uh, that part obviously in our curriculums when we are moving towards about the Hugging Face part. So that time definitely I will present when we have to move and analyze any of the models. For example, like this Gemini 2.5 Pro or this Claude. So there is, or I can say that this you will get a better understanding. Just a minute. Hope my screen is visible. I just opened the Google.
Yeah, yeah, yes.
Yes.
This just one image I'm just showing you. Yeah. Okay. Now this image is open directly. So you can see to it that this is the comparison of the models is written. Might be uh, some small, but I have to make it bigger. Hope now it's properly looks like SWE, bench verified, this kind of a things we are getting. So basically, this is I'm talking with this different models like Kimi K2, DeepSeek, Quen, OpenAI, Chat GPT 4. Cloud A4, Opus, or this kind of a lot of models are there. So this image is basically a benchmark of comparison chart of various LLM models. Okay, just like if you can see to it that SWE bench verifies means real world software engineer performance. This particular things SWE. So if you look at this cloud AOps is better with this measures on the real world software engineering performance purposes. So we can check with the help of these Hugging Face as well. where these models are present. So, or even Open Router also give you the best idea about which model is good for that particular purpose. Then SWE Bench Multinovel is obviously software engineering in multiple languages, basically. So Cloud for Sonnet is again leading there, like Live Code Bench V6, if you can see to it that. So it's live coding problems, like coding plus reasoning if you are going towards. So Kimi K2 is, you can see to it that Kimi K2 is, I think, leading here. So this kind of a comparisons in Hugging Face, or what I can say that even in at Kaggle also you can see this kind of a comparisons about which model is good for which particular purpose. So just like for the coding purpose, as I mentioned, Cloud is very good. So I can use for coding purpose Cloud. For example, if I want to write any notes or any content preparation, so I found like the Chat GPT is providing me the good way or good thing. So based on that requirement, you can utilize about these generative AI models. And also we have to always look the costing as well, because the costing is also we have to always monitor. So that is also one of these factor here. Just like these are the lot of things are given. So like tau to bench weighting, so this is aggregated tool use task basically. So Kemi K2 is basically betting maths and STEM, if you can see to it that. So this is AIME 2025 is based on the American invitational math exam kind of a things, we can say. So Kemi K2 is leading here. GPQA Diamonds is graduate level science and engineering questions. So Kimi K2 is leading here. So based on your requirement, you can use this different models. Hope I am able to clarify your question.
So may I ask one question?
Yeah, you're not supposed to say may I ask. You can directly ask.
Okay,
Not
thank you. What thing means how this chat GPT utility was built. For an example, I have seen Prologue a long time back. Prologue made some question and answer kind of logical system. So how this chat GPT thing itself was made?
itself means how this LLM is made, right?
Uh, okay, yes. Means how chat GPT was coded. I mean,
Okay, how ChatGPT was basically coded.
yeah.
Okay, so I can say that it is not like the coded with this by line like a traditional software. It was trained using the ML or machine learning on the huge amount of a data set, basically. Like that actually part I'm going to cover in this part, but let I will explain here and later again. So basically architecture, if you look up the this, so it's a transformer model. So chat GPT is based on the transformer architecture. So uh, it was, I think, if you might refer about Waswani at 2017, that was the introduced in the paper or something research paper that you will get it if you search it. So it's a decoder only transformer used for auto regressive generations, predicting the next word. Like the key concept, key components where I can say that layer normalization, positional encodings, feed forward neural networks, that kind of a thing. So OpenAI will use proprietary variety of the transformer called as the GPT, like a generative pre-trained transformer. So that was about the architecture or the transformer models, and there was a training phases. So in the pre-training, the objective was predict the next word or the token, we can say that we are going to learn what exactly the tokens. So given a sequence of previous words called as the causal language modeling, that is, so what we are what exactly that step was happening, given a sequence of previous words, and the data it is taken web pages, books, articles, code, dialogues, and more filtered and curated. And the code framework is used by the PyTorch, TensorFlow, or JAX as well. And then it done with the fine tuning. then it done with the fine tuning. So like we might see some of updated versions every 6 months or every year. We are seeing like 3, 3.5, 4, 5, this kind of updation. So that is basically we are getting the old version is going to be fine tuned on the new data set basically, or the latest data sets. So supervised fine tuning. So annotators give example dialogues and the models learns from them. So there is I can say that reinforcement learning from human feedbacks. For example, just like when we are visiting any shop, so we are getting the feedback form. And when we are going to put any feedback, similarly, whatever the response chat GPT earlier provided, or right now even, if we are giving any feedback or any prompts like, no, this is not a good answer, I'm not satisfied. So that actually he is considered as a feedback. That is a reinforcement learning from the human feedbacks, and trained to rank good versus bad responses. And a reward model is trained using human preferences, and then that word I'm not remembering, PPO, yeah, PPO, basically proximal policy optimizations that optimize chat GPT's responses. So overall, if I can say that ChatGPT was not coded traditionally, it was trained on a huge data set using deep learning and reinforcement learning techniques. And it based on the transformer architecture, trained using PyTorch or JAX, and deployed via cloud scale GPU infrastructures. And fine tuning, just I told, like human based fine tuning are key to making it helpful, safe, or aligned. So that's where actually chat GPT was coded, or we can say that trained. That the three most important things were behind of this chat GPT. And if you look for the Google Gemini, so Google Gemini is using one of the tool behind that is called as the Google search. So whatever Google search, or everyone aware about, like the biggest search engine on this particular universe, I can say that. So the Google is also performing the same way, but from where he is taking the data with the help of this tools like Google search. That definitely when we have to develop the agents now, that time I will show you about like this particular part, like how the agent is jumping to the tools and taking the information from the tool and giving you. So that kind of a things definitely we will see in upcoming sessions.
This is
Okay.
Mallikram here.
Yeah, thank you.
Sir,
Yes sir, please go ahead.
sir, you have been talking about Gen AI and other various models. So,
Mhm.
could you please throw some light on what exactly is LLM and what is its significance?
Can you come again sir, please? Actually a little bit voice was cracking, so
Now,
yeah.
so you have been talking about this generative AI and
Mhm.
various models.
Yes.
I just wanted to understand what exactly is LLM. Throw some light on LLM and its significance when it comes to Gen AI or agentic AI. Can you please?
Okay. Like you want to understand how exactly they're working?
What exactly is LLM and where, what is its importance when it comes to Gen AI or agentic AI?
Okay. What is the importance of Gen AI
No, no,
and
LLM when it comes to Gen AI or agentic AI at a high level, or maybe you can just give some, throw some light on that. What exactly is LLM and where we use that?
okay. So actually this importance of this high level LLMs or the large language models and agentic AI, uh, I just give the overview or the highlight kind of a things. So one by one I'm just giving about, like, so general intelligence across tasks, for example, like high levels or these LLMs like the chat GPT for Claude, or The importance basically lies in general intelligence across tasks, performing reasoning, summarizations, translation, coding, and also adapt to a wide range of domains like medicine, law, education, software. Like for the example, I can say that a doctor can use a high level LLM to explain complex diagnosis to patients in simple terms. So where we can use that particular LLMs as well. And the second one is context awareness and memory. So it can hold longer conversation and understand context deeply. So newer models have long context window, like 100K plus tokens are there that we are going to see to understand book reports or meetings as well. I will show you that particular examples as well. Uh, for example, this is Chat GPT or this is Gemini. If I will go here, for example, and taking about 2.5 Pro models. So, for example, if I'm going to upload some file here uh, in my system, so this is I'm just uploading memory bank. Okay, this is memory bank. Obviously, it's a coded file. Okay, now you can see that as I told, like it's context awareness and memory. This newer models have a long context window. Uh, this Gemini 2.5 giving 1 million context window as well to understand books, reports, or meetings as well. And if I will just give something prompts like what exactly this PDF have. For example, I'm asking, so it store this particular first, this model is going to be store this particular PDF in their memory. And if I will ask about a lot of problem statement or the questions related to this PDF, it can give me about the response as well. So this 2.5 Pro model is more thinking model, more in-depth, deep research kind of a models. So it's kind of a things maintain context or this particular things we are getting. So that is we can call it as the context awareness memory. And zero shot and few shot prompting as well. So that actually we are going to see in today's sessions and as well, like learn from minimal examples, no retraining needed, great for rapid prototyping and one time task, and tool use and API calling as well. Can integrate with tools like Python, Google search, or internal APIs. We can execute code, query database, or control devices as well. So this is about LLM. But when we are talking about the agentic AI or the agents, so agent don't wait for prompt. They observe, plan and act it. And it can break down a goal into subtasks and handle them basically. Like if I will ask about find the best apartment in Mumbai with rupees 50,000, an agent will search, compare, filter, and give me the output. So that kind of a breakdown the agent is going to do. And in agents, there is a goal-oriented behavior. Like instead of returning one-off answers, agent purse goals like plan a trip, write a blog, build a reports. So that kind of a things it's giving or creating that agent. And also we can say that multi-step reasoning and tool chaining as well, like chain tools together, browser, calculator and database. That kind of combinations we can do in that particular things as well. It's like analyze competitions and write a marketing plan. That kind of a prompt, if we are going to, it will divide the task. And obviously the memory bank is there as well, memory and reflections. Agent remember past actions and improve over times, reflects on errors and refine strategies like auto GPT or baby AGI or this ADK or LangGraph or a lot of things we can say that about this particular things. So that exactly we can say that as a high level summary of this LLM. So in real world impact, if we are calling as the area, so there are business, healthcare, education, software dev, research, lot of our area. I'll mention few of them only. uh, High level LLM plus agentic AI impact, I can say that automate reports, customer queries, market analysis, diagnostic assistant, patient educations, personalized tutors, personalized tutors, grading assistants, software dev, autonomous debugging, code generations, research, auto summarizing papers, and everything. So we can see to it here as it is. So that exactly we can say that the role we can take the LLM or the agents and we can play accordingly this particular things.
Thank you. And I have another
Sir,
question.
okay. Sorry. Please go ahead, Malik.
No
Please go
problem.
ahead. Yeah.
Based on a person's medical records, can it predict what will be the health issues in future?
Yes, sure, 100%. It can predict.
Will that be accurate?
No, see, the accuracy is always if you can see to it that what it's written about, Gemini can make mistakes. So if you write anything like anything like quantum physics or something, like if I will write 10 lines, if I will write it, it always give you something like it's a generative AI models. So we have to check it before we are processing or we have to perform anything, something like that, because they are all the generative AI models and obviously they are trained on a huge data set. So it might happen like they might be wrong as well. But yeah, uh, based on our own custom data, we can come to a certain decisions. For example, just like you mentioned, if you have some of the healthcare data, and based on that, for example, if you taken about the healthcare data of respective disease, uh, and you fine tune on that disease or on that disease, so definitely the accuracy is increases. Just like I did one project for one of the my client, where my client is related to the healthcare sector. That client name I cannot take on call, basically it's a US client basically. So his actual work is like they are not actually healthcare, they are healthcare supporter. What happened in USA, basically there are a lot of patients relatives or caretakers are there. So they want to prepare some of the applications, uh, and in that applications we have to use LLM basically, or agents, basically chatbot basically I prepared. So what his work is basically, the LLM should be trained in a such a way, like when the caretaker or when the relative is going to be passed the patient detail, anytime when he is going to be passed the patient details, so the LLM or the agents or that chatbot should respond in the same manner. So LLM is always providing the same things, and based on his health conditions, he can suggest the best diet plan for 5 days, what kind of a food he can take in the morning, what exercise plan, that is also he can give, and based on that, a lot of action items he can take from this LLM or that chatbot as well. So yeah, that is possible, but you have to train on your own custom data. But that accuracy is also not 100%, because these all are the machine things, and machines are not absolutely 100% correct every time. So but if in general you will ask for the chat GPT or the Gemini, definitely I can say that it will hallucinate, because it trained on the huge amount of a data sets, that is totally fine. But when you ask about what will be the future disease will come, it will give in general result. But if you train or if you do some fine tuning on some custom disease, and based on that disease, if you ask like what will be the new disease will come in next upcoming year, based on that, definitely the result will be little bit of best, as better or as compared to the uh, not fine-tuned models. So that we can say, or we can conclude here.
So that does mean that
So,
there will be
yeah,
deep fake. There could
That
be there could be a possibility of deep fake, right? Like we keep getting messages on WhatsApp saying that something has happened or some mishap has happened or something of that sort with an image.
yes, yes,
So that is all kind of fake, right? I mean, meaning a deep fake, right?
yes. Not all messages are correct, so we have to always verify it. So that is something a lot of times they are fake as well, because AI is just like a helpful, it's like a dangerous as well. So we have to always take care of that particular things.
Okay, sir. Thank you.
So, sir, one question, like when we talk about fine tuning, I mean, there are methods such as PEFT or LoDA in fine tuning, but it involves lots of costs, right? So there is
Mhm.
always a trade-off between RAG and fine tuning. So which one is recommended as per you?
RAG is like a compromise. Okay. When we are talking about the RAG, it's like a compromise kind of a things. Okay. So fine tuning is always the best option whenever we have to deal anything. But yeah, obviously if we need a good product, if you need a good things, we always have to look for the high configuration machines, GPU based or that particular thing, so that would be the costly. But if you ask for me, like fine tuning or the RAG, which option is the best, so I will always suggest fine tuning, because RAG, what we are doing the vector embeddings. Okay. And with the help of LLM, we are doing the, or that embedding models, we are converting that words into vectors, correct? So it might happen sometime the vector conversions will be not proper, or it might happens like you use, if you have 100 set of records and 500 set of records, you prefer one other models, and the 500 set of records you might prefer other models as well. Okay. So that time the quality of the embedding should going to be changed as well, and when you pass input any queries or something, your responses are going to be different. So, and RAG is obviously, we are, when the other options are going to be closed or other doors are closed, that time we are going for the RAG implementations.
After like we have a rack structure. After
Mm.
in that rack structure also, can we do fine tuning? For example, parameter efficient fine tuning, PEFT, and all these things. Or
So then why we should prefer for the RAG as well, if we are going to the what I can say, that fine tuning. Uh, so why the RAG is also required? Or you asking the question to me basically? What exactly?
that only, like RAG is basically like you upload a PDF and ask question. The same thing
Mm.
can be done by fine tuning also, right? Like when
Mm.
you uploaded this file in Gemini,
Mm.
basically I wanted to know, is it RAG behind the scene, or is it like PEFT, like fine tuning is doing the work?
Fine tuning is doing the work basically.
Okay.
See, RAG is basically what actually happening. Whatever you definitely we are going to cover, but I'm giving in a short. Whatever your data is going to be converted into the vector and store, and when you pass that query, it going to be entered to your database and searching the best similarity or that kind of a thing, and providing the result. That is the only the RAG, or retrieval augmentation say generations. So that is something we can, but definitely when we have to come through that particular topics, we will discuss more about that particular part. Okay.
Yes.
Yeah. Thank you.
One question I have, sir. You actually mentioned like about 5 to 10 minutes ago about the agents. So the agents actually learn, and from their experience they take some kind of a step or something. So, sir, one thing I've also observed when I use these generative AI, okay, so after like a few times in the same chat, so he can also like take steps based on the experiences of the answers responded prior. So we can say that the generative AI is also like an agentic AI as well after a few responses in the same conversation,
uh, Generative AI is also,
like agentic AI also then, because these chat GPT they also start thinking on their own and they also give it answers that are following the responses prior in the same chat, I'm saying.
no, we cannot uh, tell like this particular thing, because as per my experience I cannot comment this particular things, because generative AI is not automatically agentic AI basically, but agentic AI can be. Uh, so at least I will let me go through with this particular, that you I understand, because in the same context if we are continuously chatting that we are getting the response, but that is a different scenario, and the way agentic AI or these agents are behaving, that is a different scenario. So let me study about that particular things, and definitely I will come back to your questions in upcoming sessions as well. Okay,
Definitely. Thank you.
because
Yeah.
if I'm not sure I cannot communicate here, so that's the actually
True. True. Yeah.
things, yeah. Because half cooked knowledge or uh, short knowledge is always a dangerous, so that's why actually I have to look that particular thing. But yeah, that's a good question as well.
Sir, can you give one example of agentic AI?
Can you
Sir, can you give one example of agentic AI?
agentic AI in sense means I'm not getting exactly.
Like generative AI examples would be ChatGPT, Google Gemini. What would be the examples for agentic AI?
You can take the ADK is super. I can say that if you are going to search like this ADK, you can see that agentic development kit is in front of you. So ADK, you can see that this is agent development kit. If you just get a time, just go through it. A lot of things are there in agentic development. So this is agent. You can use it, this agent. There are a lot of agents are there. We can use a lot of agents, but yeah, definitely we will see in upcoming session. But if you understand about agents or something, the conversational agent is there from the Google. So there are a lot of agents are there, not about one or two agent uh, like the ADK or something like. But there are plenty of agents are there. So
Okay. Thank you, sir. Thank you.
Auto GPT is also one of the examples you might hear. Personal assistant. You can create your own agent as well. So we cannot give the exact about like AI research. I will definitely this sessions will going to be more interesting in the
Yes.
upcoming times, because today is the first day, and when we will enter to this agent world now, that time you people will definitely enjoy that. That is not a big deals. Like you can create your own e-commerce product optimizer agent as well. So it's agent we can create with the help of LLMs.
Okay. Sir, you have
Because
trained. Yeah. Yeah. Sir, you have trained me before, and I have attended your previous MSME sessions. So it was great back then also.
okay. Thank you so much for your feedback. One more things I just want to highlight here. Just like we are using the toy for our kids or children's, and inside that there are batteries are there.
Yes.
So similarly, the agents are something like we are built up for our own task, and in behind that or the engine is obviously the LLM. So we are training the giving the training or the instructions to the LLM, and based on that instruction your LLMs are working basically. So anyway, we are moving towards the next part, and
Okay.
definitely we will discuss more about when the topics will comes in the upcoming things. Okay, so we are moving towards about like how does this generative AI is work. So generative AI is trained on a huge amount, like that's obviously I covered about this particular things. The types of generative AI are the text generations, image generation, music generation, that already I covered. uh, my question is related to not questions basically. The first I will ask questions for things like why is generative AI a big deal. So yes, we can say that it save a time, write a blog post in a seconds. It boosts creativity, artists, writers, for everyone's. It powers chatbots and virtual assistant. This virtual assistant is called as an agents. It helps automate content creations for businesses. It can personalize experiences like your own AI tutor or doctor, something like kind of a things. It risk and challenges are also by default is there when we are using the gen. Just like someone was called about like deep fake or something. So yeah, that is they always challenge like fake content, deep fakes, videos or voices that look real but are fake. Bias, it can repeat harmful stereotypes. Plagiarism, might copy from training data. Over reliance, people may trust AI too much, so that is also difficult, because I'm telling one scenario. Like in my working times, there was a one project where we have to build a rag, traditional rag, but some candidate might taken the code from what I can say that from this ChatGPT or any of the tool. I'm not remember, not sure which particular AI LLM he used or she used. They just copy and paste the code and they run it. But there in the code there is an infinite loop in such a way, like what I'm just want to say. Suppose if I have 100 row, so how that particular things is happening, when the first row's vector is going to be converted. Okay, first row's text vector is converted, and when the second row is going to be start, then first row again comes in a pictures. So this operation is continuously, or we can say that infinite kind of a way is happening. And my client is faced about the 35,000 USD billing in just 12 to 14 hours because of that particular uh, things. And only I can say that uh, there are total 1 crore of records, and only 8,700 or something kind of embeddings are generated. So you can understand like how much this if we are going to believe totally to this AI, definitely it would be a dangerous as well. So my request as well, like we can take the help, but we cannot believe blindly to any LLM or any AI models. So it, because they are also trained by human. So if human can do the mistakes, definitely LLM can also do the mistakes as well. So that's about the generative AI. Anyone having any queries, concerns, questions related to the generative AI, or whatever things I try to elaborate, to present in front of you, to explain in front of you, anyone have any questions, queries, please, you can shout or you can write in a chat as well, guys. I can see your chats when you people are going to write, because I partially open one more window with very small way, so I can see the chats as well. So in between, if you feel any things, or if you raise hand, definitely I can see your hands or your things as well. So that's it. So we have to move ahead with the next part about this particular things. uh, LLM architecture. Hope this architecture in front of your screen. So let it be. Now, coming to the architectures or the nutshell, what we talk about, transformer in a nutshell. What is LLM? That's already a large language model, is a type of AI trained to understand and generate language. It is called large because it is trained on massive amount of text like books, Wikipedia, websites, plenty of the thing. Joe source, whatever source you will provide, it capture and it train. That's it. So just like you people might ask about like how it developed. Just like we every day you might seen about a lot of people's might searching on GPT, Gemini, or Claude, or any LLM models, and you might see a lot of data they are going to pass. Ghibli, the trend you might see in between the Ghibli. I don't know. I mean, no, sorry, not I don't know, but I'm sure you people might aware about the Ghibli trend. In the meantime, there was a Ghibli trends are going on, and with the Ghibli trend, if you might see, a lot of people are with what we can say that uploading their images and writing the prompt or something like that. What they feel or what we feel, can Gemini or this LLM models are not going to capture those data or use for the training phases? They are. If you see the Meta policy, Meta Llama policy, he clearly told we are taking the data for the training phases as well. So that is something every day, lot of issues, lot of questions, lot of things we are passing, we are giving to LLM models. So LLM models every day are, I can say that, taking a lot of data and develop themselves.
Can you just zoom into the architecture of this encoder decoder transformer layer? Yeah, thank you.
Is it
Yeah, it's visible now.
okay? Okay, thank you. So just give me a minute. Just 1 second, 1 minute, I will take it. Yeah, we have to start. Actually, there is a message comes from, so that's why actually I taken about this. Yeah, there is one message from my home, so that's why actually I was asked to just yeah. Now that LLM are built on transformer. I have to show one more image. That's I think I built up, but where it's on actually. Anyway, let's have first cover this. So LLM are basically built on transformer architecture. Okay, the transformer is like an engine inside a car. Just try to understand in a very simple way, or in a layman way. I'm trying to elaborate. It it's what makes the LLM work. So what is transformer? Transformer, or let's say you give the sentence: the cat sat on the mat. So a transformer does not just read one word at a time. It looks, or I will just give something like that. Yeah, just give me. Just a minute, guys. Yeah. So this is I just taken for this slide to elaborate. Yeah. So for example, if I will write one statement here, the cat sat on the mat. So a transformer does not just read one word at a time. It looks at all the words at once and it tries to understand the relationship between words, even if they are far apart in the sentence. So how actually the transformer, or what is a basically transformer? Just try to understand. So transformer does not just read one word at a time. It looks at all the words at once and tries to understand the relationship between words, even if they are far apart uh, in the sentence. So main concepts in transformer, basically the main concept in the transformer, like the one is that already you might aware, is that embeddings are going to be what exactly happening here. Embeddings are going to be words are turned into numbers, or we can say that vector basically. So how it's coming as the example, basically I can say that embeddings, that it's a very basic things. So words are used to convert, or used to used into vector or numbers. Best you can remember as the number. So and inside that we can say that vectors.
Sir, the algorithm would be SVD, right?
What SVD? Standard
Sir,
value.
yeah, that one algorithm.
Yeah, yeah, SVD is standard value decomposition. Yeah, that. Yeah. So in that there is a word like the cat said. So if I'm taking the cat for example, so the cat is going to be converted here in terms of vectors, and you will getting a 0 point 0.45. This is randomly I'm taking. I'm not sure about this is correct or something. 0.23, 0.75, and so on, if it is there, something like that. So these vectors are capture meanings. So cat and dog will have similar vectors. Cat and dog have similar vectors. These vectors capture meaning basically. So cat and dog will have similar things. Now this is first one is we can say that main concept I'm talking about the in a very simple way I will try to explain here. Not I'm talking any algorithms or something. Any so those who are belongs to non-tech background, those who are not aware about any ML deep learnings, they can also understand very easily here. So that is my main motive here. So the second one I can come up here. Uh, that is called as the attention mechanism. This is very important, guys. You can see that because Gemini is built in here. You can see it with that. So I'm getting a good suggestion here because Gemini is obviously built in here. So that I can take the help of as the thing. So this is basically we can call it as the core innovations. So basically it answers it answer which words should I pay attention to. For example, in the sentence, the lion chased the deer because it was hungry. So what does it refer to, the lion or the deer basically? Or I can say that for example, this will be the best way. For example, the lion chased the deer because it was hungry. So what does it refer to, the lion or the deer? The attention mechanism helps the model figure this out by giving more weight to the important words. Like think of attention like a spotlight. The model shines a light on words that matter most while understanding a sentence. Whatever it may be, the sentence, like India is my country. So there might be the India or the country might be the most important words will concern, and the model shines a light on that words that matter most while understanding that particular sentences. So this is the basically about uh, the attention mechanism. So it basically answer which word should I pay attention to. So for example, if I will take about like the lion chased the deer because it was hungry, so the lion and the deer, or it might be happen like the hungry is also be the important words. I'm not coming saying like these are the two only the words which are super important. It might be the 3, 4, 5, 6, 7, 8, 9 words might be the important in the respective sentence. But for the understanding purpose, this attention mechanism is always giving, or the model always shines a light on words that matter most while understanding the sentences or the sentence. You can see to it that. And once it understand about that particular things, then the third mechanism will, or the third thing is coming, that is called as the self uh, attention. Just like nowadays we are doing the self attested. So attention, because government is giving us like we can do the some of the self attention attested things as well. So this means the models pay attention to every word in the sentence, including the current word itself, and this allow it to understand context really well. So in this particular part, if you can see to it here, so every word in the sentence, including the current word itself. So this allows to understanding for the models is more contextually or very well, I can say that. And then the fourth layer would be coming here about this particular part. I can take it, this particular is the, just give me a minute. So I can little bit smaller here. So the fourth one mechanism is like the layers and heads. Layers and heads. So transformer have many layers like an onion and multiple attention heads. Layers like the convolutional layers or something like you might hear it already, those who are belongs to. But I'm not going towards more technical in depth here because a lot of people are not quite familiar about this deep learning machine learning technique, so they might miss about like which layers, it's like the hidden layers, which layers exactly. So I'm not moving more that in depth about this particular thing, but with the simple example, just like onion, you might see there are multiple layers are there. So similarly, this layers are this, when I'm talking about this transformer, deep learning, generative AI, these are like that, they are always mimic like a human way. So that obviously you understand, just like in our brain there is a neurons, similarly here are the neural networks or the layers are there. So in this particular layers and heads, so layers are means basically when I'm talking about the layers, it is, we can call it as the deeper understanding. And when I'm talking about the heads, it's multiple perspective on meaning or meanings. So each layer helps refine the meaning of the input. That's how GPT models become so smart. So try to understand about this statement. Each layer helps refine the meaning of the input. Just like these, deeper understanding, multiple perspective. So as I told that there are many layers are there. So each layer is going to be understand. For example, just I given one example about when we have to train the kid. So the kid might understanding the first day little bit, second day more. So there is a stage wise kind of a stuff would be there. Similarly, stuffing kind of a things we can say that are layers we are getting. So each layers refine the meaning of the input, and that's how this GPT models uh, become so important, so smart, or the LLM models are so smart. So this is one, and the last one is last part is we can talk as the positional encoding. Positional encoding. So unlike humans, transformer don't read from left to right naturally. Okay. So we add position info to the word vector, so it's know the order of words. Example, cat chase dog. That is not equal to, or I can write about this particular thing, so you will get the understanding as well. Cat chased dog. Cat chased dog not equal to dog chased cat. So positional encoding keep this order intact. So this positional encoding is super important as well here in this particular things. So model is trained to predict the next word input. The sun is in the, so the target would be what? Sky. By doing this million or billions of times, the model learns grammar, facts, reasoning, and even creativity as well. So that is the way we can say that model is trained. Just because when we are talking about it's a 80 billion parameters, 70 billion parameters LLM models is there. So That means it doing a multiples parameters it's train, and for each parameters it might train a million or billion of times. When I'm talking about the parameters, I can give one simple example. Instead of parameter, just try to understand about the features. For example, if we are going to predict the salary of employee, so there might be the skill set one features, experience one features, domain one features, organizations one features, this different things, or degree one features, or this kind of a features we can build up. So we can call these are the parameters. Based on this parameters, we can predict like the salary of the employee or the salary of the person. Similarly, these models are also trained on a billion of parameters. We cannot imagine even what are the parameters in this particular world. So that is something we need to understand about this. And for one parameters, for example, just like if I have a model X and I'm going to train for one parameters of million times or billion times, I don't know like how many people are going to write on ChatGPT or any particular thing like the sun is in the dash, the sun is in the dash, the sun is in the dash, any particular. This is just example I'm giving about this particular things. So when the model is going to be trained on one particular sentence or one particular things, like on one particular statements, million or billion of times, the model learns grammars, facts, reasoning, and even creativity as well. So when you give a prompt like, tell me a joke about robots, for example, when I am giving the prompt, like tell me a joke about robots, so what things is the model is work. So the model convert the prompt into vectors, use the transformer layer to process it, and outputs you will getting, why did the robot go to or go on a diet? Because he had too many bites. So we are getting the output, this kind of a things, and based on that particular multiple transformer layers to process it, it understand a lot of things, and this entire process are happening. Embeddings, attention mechanisms, self attentions, layers and heads, and positional encoding, and based on that we are getting a output which are related. It might happen sometime you are not satisfied with the answer, sometime the answer is wrong as well. So based on that, it converts the into vectors, and then attention mechanism, then self attentions, and then layers and heads, and then positional encoding, and we are getting the final output. So that is the actual work of I can say that this particular things here, how the transformer or this particular things is concept or main concept in transformer. So this is the way you can remember it. This is the main concept of transformer. Now uh, we are moving towards about the next part, that is called as the tokenizations. Now, like how text becomes input. I will later show you about how we can calculate the tokens as well, about like in the live way. So tokenizations. So just give me a minute. Let how to take it a duplicate one. So this would be the tokenizations. Tokenization. I will share the PPT later on. I have other materials as well that I will also share it with all of you, or this team as well. This MSME team I will share is basically what happened. Tokenizations. For example, if I will taking one example here. Example. The word is unbelievable. Forgive me if I will do any spelling mistake, guys. So basically what happened, UN believe able so that's why I told like if I will forget. So text is split into a small chunks called as the tokens. Text is going to be converted into split into a small chunks called as a tokens. Example, unbelievable. So it's converted into UN believable. Each token is turned into a vector and processed by the model. So this is called as the tokenizations. So and this is going to be done it here about this particular things. If I will write about the full pipeline summary, so the first is like text inputs, whatever you are going to pass is going to be converted into tokens, and from that tokens it's converted into embeddings. The second is this embeddings is going to be converted into the positional info added. Third would be run through transformer layer with attention memory or attention, I can say that attention. Then you are getting the output, that is next word token predicted, and repeat until complete output is generated. So this is actually, you can remember it, this full pipeline summary. This is the simplest way you can remember like how the transformer is working. Let's say the sentence is the quick brown fox jumps over the lazy dog. So inputs gets converted into tokens, and each tokens gets an embeddings. Self attention lets each word see the others. Layers refine this understanding. Model predict the next token step by step. So that is something we can say to it, that and putting it all together, generative AI is what AI that can create new content. LLM, a brain for the language, trained on massive text data. Transformer, the core architecture behind LLMs. Attention, the magic trick that lets the model focus on what's that importance. Tokens and embeddings, the way language is converted into math for the model to understand. So that is actually all about, I just highlighted putting it all together here, and we are getting about this particular things here. Let's, I have to build one image I already prepared. This is, so you can just, I was search earlier. So this is the way actually it's working. Just see to it that generative AI that create text, images, music. LLM, a powerful AI model that understand and generate human like text. Transformer is a nutshell. Attention helps the model focus on the most, embedding a number based meaning of that particular things we are getting here about this particular. But when we are talking about this particular part here or these things, let's, I have to first to share it. Yeah, mode should be EV.
Sir, this is Mallikram here. Sorry to interrupt you.
Yeah, please go ahead.
So what is the difference between transformer and this one? The one that you were referring.
Transformer and GenAI or LLM, what exactly?
No, 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 no. Can you please? Just now you were covering that, right? Transformer.
Transformer and, please, you can just tell me which.
Not embedding.
Embedding.
No, 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 no. Transformer and I think tokenization. Yeah, my bad.
Yeah. Okay. See, tokenizations, that is, I already told, like whenever we have any words, something like, okay, so we are going to convert into the small chunks. Just like in your example, you can see that unbelievables, that's unbelievable, or India is my country. So India, one might be converted into IN, DIA as something, is as one word, or small chunks as it is. So that is something we can called as uh, tokenizations. When we talk about the transformer is something that is the engine, we can say that it is inside the LLM that basically processes the language basically. So that is, we can remember as the transformer. Transformer and tokenizations are the different scenario. Tokenization is something like the process, whatever the words are going to be converted into the tokens. For example, any words you can take, just like I given the example as the uh, one example, the quick brown box jumps over the lazy dog. This is the one statement. So first, that inputs, these are my inputs or these are my prompts. So that prompt is going to be converted into the smaller chunks. So that smaller chunks would be like, the would be one chunk, quick might be one, brown would be like divided into two chunks. It might happens. They have already used different models, NLP models there, and they are going to be converted into the smaller chunks there. So that is a tokenization. But transformer is like the engine of your LLM models, or that is a nutshell. That's why I prefer about like the core architecture behind LLMs basically. So uh, I'm coming to this particular. Hope you understand about like the tokenization and transformer, Malik.
Yes, sir. But even in transformer, it is
Mhm.
mapping to some numbers, right? That's what you said. Each word, it will be mapping to some number. I think if you can move back to that slide or somewhere you were, you,
This one.
this one. Yeah, yeah, embedding
So
word.
that's actually I told about, like, these are the concept of the transformer, but how the embeddings are happening.
Oh,
See, when you are talking about uh, transformer is mapping some numbers. Transformer map numbers to other numbers, but why numbers? Because computer does not understand words. They only understand numbers, vectors, matrices, tensors. So let's say you give a sentence like "I love pizza." So the transformer does not directly understand these words. So it use the tokenizations. So the tokenization is going to be converted into the small chunks like I, love, and pizza. And that small chunks is going to be converted into the or each tokens gets a unique number. Try to understand, or embeddings that you can understand in a way. So each tokens like I would be, we can say that 101. Love would be, we can say that 2057. Pizza would be, we can say that 3891. This kind of, I'm just giving randomly number. Don't take it that number is something. So I love pizza is going to be defined in a number way. So the number are just IDs, not actually meaning yet. And the second step, embeddings, convert token IDs into vectors. That is the meaning. So I is going to be converted like into the embeddings. Love is going to be converted, then pizza is also going to be converted. So it convert into the vector embedding, and then self attention is coming in a pictures, that query key value about that particular things. Then there would be like more mapping, like the layers would be there, like that layers we can call it as the feed forward networks, but I'm not moving much into the technical because a lot of audiences not aware about a lot of the flow of like forward feed forward neural networks and all this particular thing. So they will all might get something like the bouncy thing. So I just try to simple way. This is actually the main concept in the transformer, but this embeddings is converted not directly. The embedding is converted after the chunks. So that's why here I written about like full pipeline summary for this particular transformer work basically. So first the text input is converted into the tokens, and that tokens is going to be converted into the embeddings, and then embedding is the positional info added and it's run through transformer layer. That is layer we can call it as the feed forward network basically. That is a more mapping way we can say that uh, particulars, and we are getting the output like next word predictions or something like that.
Okay. Thank you. Got it.
So also I have I can write here if I will get a permissions to. This is a view version. So just go view. I will take the mode as the editing. So so this is also you can words, tokens, vectors, process, new vectors, output tokens. That is something we are getting about. So the transforming is mapping some numbers, but now not exactly what numbers or how wide. So that particular things definitely uh, the transformer is working here. Now next we have to move ahead to understand about this particular one. I just to highlight and then we'll move ahead with the prompting part. See, that's why I told about don't take the 30 hours, guys. This is just humble request. It might happen that hours would be increases as well because the topics are heavy. So sometime it required to explain in a different way. So please don't mind it if more than 30 hours would increases. That's why during the first day I just highlighted this particular points, but I will try my best to finish in 30 hours. But if it is not covered, so we'll have to take at least more 3 hours or something like that. I will try to cope up because in between the sessions the some sessions are more heavy, not the first day or the second day, but in between when we move towards this rag agents or something like that, that time actually. Anyway, let's we have to move ahead with the next part and try to understand about this particular uh, basically architecture we can say to it that I just apply here. This is basically more as a technical in-depth. Those might have the understanding of the technical in-depth, they might get the understanding. That's why I tried my best way to explain, and I just want a quick uh, review for this particular things. So just give me a minute.
Just one question I have.
Yeah,
So this
please.
is regarding the difference between attention and self-attention. So I believe that after the embeddings are done, it's passed into the self-attention in the encoder layer. So where does attention work? Like, is it before it just before it goes to the decoder, or like how?
After can you just come again please?
Yeah, so the self-attention, after the embeddings are created, it goes into the self-attention, right? So where
Yes.
does the attention work? Does it work just after the encoder passes it to the decoder? Is that the step where attention work? This it's basically the difference between attention and self-attention that I'm trying to figure.
Yes. So basically there are two things like encoder and decoder that actually I was supposed to explain those particular architecture, but anyway, let's say as you ask about this, so let's I have to elaborate about encoder and decoder here about this. So attention works in both the encoder and decoder, but in a different way. For example, when we have the component encoder, types of attention used as the self attentions. So the purpose is like the learn relationship between words and the input basically. And in the decoder, the type of attention used as the mark self attention and cross attentions as well. So learn from its own previous outputs and look at the encoder's outputs as well. So that kind of attentions is going to be working in this particular parts. Just like as I given the example, the cat chased the mouse. So the job of self attention here is to help each word pay attention to every other words, like including self to understand the full meaning of the sentence. For example, chased pay attention to cat and mouse to understand who did what. And this basically helps the model understand grammar, meaning, and relationship. And why is it called self attention? Because each word looks at all other words in the same sentence. And this is I talk about attention in the encoders. Basically the things which I talk, it's talking about the attention in encoders. Now attention in the decoders, the decoder use two types of attentions. One is called as the mask self attentions, that is we can say that lock kind of a things. Decoder is generating the output one token at a times. Like let's say the decoder is trying to generate a Italian for I love you, for example. So during training at time step T, the decoder should only look at the previous words, not the next one. So it use mass self attentions. That word is something like mo, can see, and t, or something like kind of a words, but not molto. It's mass, some kind of a things. So this basically prevents cheating and ensures the models learns to predict the next word, not to copy it. So that is the work use of this mask self attention in these decoders. And one more thing is like the cross attentions in the decoder, just I mentioned earlier. So after self attention, the decoder uses cross attentions to focus on the encoder's output, whatever the encoder's output were there. So for example, decoder is generating tiamo. Tiamo is obviously Italian word, and cross attention helps it focus on I love you from the encoders. So it learns which inputs words are relevant for generating each output words. And this is the bridge between input and output in the task like the translations or something like that. So in the encoder, there is only self-attention layer, but in the decoder, self-attentions, mask, and the cross-attentions layers are also there. So that is the way actually in this encoder and decoders are working. So that's actually I want to explain here about this architecture basically. So this architecture is basically, hope I answer your question. First of all, let's
Yes, yes, sir. So this masked attention is basically self-attention, just that the next words are masked to prevent it from cheating, right?
yes, yes, yes.
Got it.
So this diagram basically shows uh, how a transformer based model like GPT or BERT learns during training, particularly in a sequence to sequence task like translating English to Italian kind of a things. If you look at this, let me zoom it a little bit. So if you look at this particular something Italian kind of a things is utilizing, I'm just giving overview because it's more technical kind of a things. If those who are not belongs to technical, just like first year engineering students, they might difficult to understand about like the exact working, but it's not necessary as well about here to grab this, because I try to explain in a very easiest way like how exactly this particular thing is working.
So
So the
one
input,
thing, one thing may I ask? Means all these attention, there is money. I did this just last month. So one paper is there. Attention is all you need. That explains all these things, right?
yes.
Okay. Thank you.
So the encoder input is here. Uh, it reads the entire input sentence, and each word is converted into this chunks, vector embedding. That obviously you are aware. It's just like I love you, numerical vectors that carry meaning plus positions. I already given the example here. So encode output, encoder, sorry, not encode, encoder output is there. So the encoder outputs basically a representation of the whole input sentence, one vector per word, one vector per word. But it is not just the meaning of that words. Thanks to the self-attention mechanism, each output vector also knows how the word that words related to others in the sentence. For example, it knows that love connects strongly with you in the sentence. And next one is, if you can see that decoder input, the target sentence in Italian, the target sentence is in Italian. It is given as an input, but shifted right. But shifted right. Why? Because we want the model to predict the next word. That's why it shifted the right. So we, or this is called as that. Also, we can call it as the teacher forcing. So where we give the correct previous word to help the model learn faster. And in between, if you can see that this blue, sorry, not blue, purple one, decoder. So think of the decoder as the writer. So it takes two things, the previous words in the target sentence, that is like as a T, and the encoder output, if you can see here about this particular, just like I talk about like this self attention and that particular things. So the encoder outputs the encoded meaning of the English sentence basically, and it tries to generate the next word in Italian, example amo. It trying to generate the next word Italian, that is called as the ammo basically, this particular things. Inside the decoder there are also self attention layers to look at the previous output, and cross attention layers to look at the encoder's output. So the decoders learns, oh, the English sentence says I love you, the next word in the Italian after T should be amo or ammo, whatever it may be. So that is something it's going to be happening here. And in the linear layer, if you can see that this layer takes the decoder's output vectors and turns into the big list of scores, or one for each word in the vocabulary. For example, if your vocabulary has 30,000 words, so you will get 30,000 scores. And then is the softmax layer, if you can see that. So the softmax function turns those scores into probabilities. So it outputs something like ammo would be 0.82 probability, gato would be like 0.003, this kind of a different probability, molto would be zero point 0.0, different words probability. So it's saying 82% probability or 0.82 probability is there, so sure the next word should be ammo. So that is something you should understand about how exactly it happens in one time step, how actually uh, happening about this particular things. One more thing is like about this loss function. Now that is cross entropy, if you might see here about this, how loss function is basically what that you understand in a very easiest way. We check how close the prediction was to correct the answer. If the correct next word is ammo and the model said ammo with 0.82 probability, that's good. If it's predicted a completely wrong word, that's bad. So we use, or in this particular architecture, use the cross entropy loss to measure this difference between predicted and the actual answers. So the goal during training is to minimize the loss so that the model gets better over time. So that's why the loss functions is completed in this particular in the pictures. And if you look at this particular things, the bottom right zoom diagram, transformer block something. So the encoder block, left side is the inputs, positional encoding, multi-head, self-attentions, feed forward neural networks, repeated n times stack layers about this particular things. Decoder block at the right side about this particular same structure, but with marks self-attention and cross attentions to read encoder output and to prevent cheating by seeing future words. Decoder input is shifted right, meaning it sees only the previous words during the training. Just give me a second, guys. Yeah. So it all happens in one time steps. This training step is called a single forward pass, and all the words in both the encoder and decoder sequences are processed at once in parallel. So this thanks to the transformer. Basically, this is why its returns time step is equal to 1. It all happens in one time step. This is very different from older RNN models that process one word at a time slow. So that exactly about this encoder and decoders. I try to not use about more technical things, try to use a simple way to elaborate this nutshell of this trans this particular architecture, and I also build up this particular thing so that each and everyone can understand very easiest way about like how this particular sorry how this particular things are working here, this particular things or this workflow of this transformer as well, or how this particular things are happening. So that is about the explanations of the first part. I try to elaborate this particular things uh, till here. This I will cover temperature top K in this particular mastering prompt engineering. So that's why I have not covered here, because in the prompt engineering it's important, not here it's important, guys. So that's why actually I kept this particular things as it is. Now we'll move to the setting up environment. Still anyone having any questions, queries still here, this particular things? So just let me know the context window, temperature, top K. I will explain while when we have to use LLM models for prompt engineering or mastering the prompt engineering part as well. So because that time this part is also comes in a picture, so that's why I keep this particular things as it is. Anyone having any questions, queries? Hope you people enjoy the sessions. If you need any break or something, 5 minutes, 10 minutes, let me know. Definitely, you can tell me, guys. Not to be. And I just want to a quick review about things. I think some one candidate was mentioned like she just completed about first year engineering or something, first year degree college something. So is there like uh, you are feeling something difficulty still, whatever the concept I elaborated? Are you there in the meet? Can you just elaborate a
So
little
yes,
bit
sir,
about
I
your
am
understanding?
here. Yes, sir.
Yeah,
I
yeah.
am able to keep up. In between, I have been asking Google what are LLMs and trying to understand what the terms
Okay,
are. So
okay.
yeah, I'm able to catch up so far.
Okay, thank you, thank you.
No problem.
Anyone still facing any things difficulties to capture about LLMs or something like that, or generative AI, transformer, this entire things? Anyone having any questions, queries, guys? So please, you can. Else we can go to the setup of this particular the next part. So I request first of all the candidates should go ahead and just open the Google tab, because this is important. The Google, we should make the Google will be our friend. You can see that now Google has also having the AI mode. So this is superb. Now Google is getting the AI mode. So this is something amazing. And in that particular things, you search just Google Colab. I just want everyone should follow this step, because if you look at this particular things, Google Colab I will refer instead of Jupyter, because that's it you need to require to install in your local machines or something like that. So that's why I prefer these open source platforms where we can do the practical implementation as well. So that is something I needed. Yeah, definitely, Amit. Diman, I will provide you in the WhatsApp group. I will provide a lot of contents, so don't worry about that particular things.
So this is
Yeah,
Malik. Yeah.
yeah, Malik.
I am not able to see that option AI mode which you are able to see on your Google search.
Okay, so it might be like I'm a Google partner employee, so
So
that's why might be I am getting only this particular things, and you are might not getting. But I think it's there, but I'm not sure about in the local version it is given or not.
Sir, it is
But yeah,
available in the local version.
available, right?
Yes, sir.
Yeah, yeah. So
meaning local version as in I
local
didn't.
means local means just like we use personal email ID to log in or something. So
Okay.
we are getting that's local actually. We talk.
Maybe I thought we should upgrade to some higher version or something like that.
No, no, no. It's
Google.
not like that.
Okay. Thank
Seems if you have an account and open Google homepage, it will show AI mode.
Yes, yes. AI mode. So that is something more helpful. We can say that. So let's, if I will search something like, as I told, like go ahead and search a Google Colab, guys. So you can use the Google Colab, and you can use this Colab notebook or something. Welcome to Colab. You will get this kind of a thing. So I request each one of you should use it. I have a lot of notebooks because I did a lot of things day to day. So that's why I have plenty of. So you can use the create the new notebook. So this notebook is going to be free of cost, created in your drive, means stored in the drive. So you can take the new notebooks. And once you will create the new notebooks, you will come to this kind of a page or something like that. Okay, something like the page you will get it, or I will show you from the scratch. New notebook in the drive, you can see that when I click it, new notebook in the drive is going to be open. Why this platform is important? Because whatever practical implementation, 90% plus practical implementation I will try to implement here, guys. So that's why actually I prefer this. And during the agentic AI or sometime that might be we will move to the VS Code or PyCharm or that kind of platforms. I will also provide you some of the deployment of the agents as well, because as I am a Google partner, so I have that Google resources available. And you people also can get the $300 credits if you open these Google console accounts. That I will guide you like how you can go ahead, but just 1 rupees, only one time 1 rupees is going to be debited. And just make sure you are not going to uh, go beyond the $300, because it's the charge services. So that's I will guide you. Don't worry about that. So this kind of a page, hope everyone might getting, or all can see to it that this Google Colab, or those who are already familiar, they are definitely not getting a problem. But those who are new, they can use it. And you can connect as well. Here you can see that in the free version also you will get a lot of, like if I will go to the change runtime type. I hope my screen is visible with the Google Colab, guys.
Yes, sir, it's visible.
Okay, thanks for the confirmation. Uh, so you are getting the Python 3 or Julia, this kind of a language, you can use it. So we are preferring the Python 3. You are getting the machines, basically virtual machines you are getting. And on that virtual machines it's working. So we are getting hardware accelerator is the CPU, T4 GPU also using, just like we mentioned about the fine tuning, if you remember it. When we have to perform the fine tuning of LLM models, the LLM models are very huge, and they required the GPU support. So we can use the GPU as well, and we can perform the fine tuning as well in this Colab notebook as well. We can also get the tensor processing unit as well, T4 uh, TensorFlow processing unit. So that also we can use it, but for the local task or that particular task, we can prompting and everything, so we can use the CPU because it's a light versions. It will not take too much of that particular. So if I will go ahead and click on this particular save and click on the connect, see already this my particular things is asking to connect it. So if I will go ahead and ask about like connect to T4 GPU, it will connect T4 GPU CPU. If I will save and if I will ask reconnect, in your side you will get the options like the connect only. So this something it's connecting, you can see to it here. It will take, now green is there, that means it's now sign is there. You can see to it that you can also go and see the view resources as well. So its system RAM is max to max, it can handle 12.7 GB. Disk capacity is 107.7 GB is there. So you will getting some of the disk as well. If you want to upload any of this particular data or something, you can upload it as well.
I'm getting
Okay.
an, this is Ram here again. I'm sorry to interrupt you. I'm trying to launch this notebook. I'm getting an error message. It says
Can you
quota exceeded.
just give me a minute? My mouth. Yeah, can you share your screen if possible?
Oh, sure.
Guys, if anyone feel any difficulties, you can let me know.
Maybe I'm not able to share my screen.
Okay. But what error you are getting basically?
Just a second. I'm in Colab. This thing. From Files menu, I select New Notebook in Drive.
Yeah.
Just a second. It shows up as loading, but notebook loading error. There was an error loading this notebook. Ensure that the file is accessible and try again.
So there might be some glitch from the Google Colab side, but you can try it again. Definitely it will open because it's a open source. It's not a we have to some quota or something like that.
My file storage is exhausted.
Okay. File storage exhausted means your drive is packed. Probably.
Correct. So what can I do in that?
You can just create one new email ID, any of the name, and you can just create one new email ID, or you can delete some of the contents from the Google Drive. Then only it will get a space because the notebook is also taking some spaces, na? So that's why actually.
Okay.
Or better, you can create one new email ID for this workshop purposes, and where you can store it, and you will get 15 GB kind of a Google Drive capacity as well. Okay.
Sure. Thank you.
Yeah. Now also I will ask to all of you, please go ahead in the Google and just write API Studio. API Studio. Sorry, my eyes is a little bit. So API Studio. This is for the API key purpose. So because OpenAI API key is costly, you can also use a lot of platforms are there. Grok. Grok is not that GRO key. Google that GROQ. Grok is also LLM models that is also giving the API keys. You can use this particular, so you can just log in with Google or the GitHub kind of a things, guys. But we have to go to one by one. Gemini is also giving the open source API keys, near about 30 or 30 KPI keys free of cost probably. So you can just go ahead and just create it. This is I can show you from my personal here. Just a second. Just give me a minute. Then we'll move ahead to the next one. Is my screen is visible? I just try to share the different window. Is it visible or not?
Visible, sir, visible.
See, this is my personal personal email ID. I just want to show you about you can create with the personal way as well. No need to have that subscriptions or anything. You can go ahead with the AI Studio. Okay, so that's AI Studio is there, and in that AI Studio you can go to the Google AI Studio. Google AI Studio. Hope everyone reach here about Google AI Studio. Please let me know if you feel difficulties or something to reaching the Google AI Studio.
Yeah, it's asking try Gemini or get API key.
No, I'm asking you, have you reached about till this AI Studio?
Yeah. So when
So
I
have you log in with the Google ID?
yes.
Okay. So
There
the
is
same option you are getting or what?
Now I'm getting a pop-up window with Google AI Studio. It says try Gemini or get API key.
Okay. So you can click on the get API key.
Get API key. Okay.
Yeah, you can see that in my window there is a get API key is there.
Yeah.
You can see here. So in that get API key, you might see in the plus sign create API key.
Yeah.
All are getting that's create API key.
My bad, sir. I missed out. I was in the middle of creating that Gmail ID. You have to visit this. Okay.
So this is a
I'm getting when I search API Google Studio, I'm getting it is redirecting me to a different page. Google AI Studio for developers.
yeah, Google AI Studio for developer. Yeah, go ahead.
Gemini API for developers.
Yeah. See, in a Google, you have to search. See, this kind of a things you might getting. Google
Right,
AI Studio, Gemini API, Google AI for developers, right?
right.
Just give me a minute. So this kind of things you might getting. Okay.
Yes.
So you have to sign in first. Have you did sign in?
Yeah, that's what I'm in the middle of that.
So you are getting a sign in option or not?
Yes, I'm getting that.
So have you did completed the sign in?
No, not yet, sir. I'm in the middle of this creation. Just give me a second. I'll do that and I'll come.
Okay. The rest of the peoples might see, guys. You have to just follow the simple step. Google AI Studio, Gemini API for new person who never, because in my personal also I went a lot of times AI Studio, so that's why I'm getting this kind of an option. But those who are new, they might get Gemini API, Google AI for developers. So you have to just click it and you have to sign in. Okay, sign in. Or so you can see that get your API key. So if I will click on get your API key, you can see that I will directly jump to this particular create API key. Okay. Usage and billings, everything is there.
This for actually API keys, is it a pass keys or something?
API keys.
Yeah.
Yeah, you have to create a API key here. When you click your API key, you have to search a project or something like that. What you are getting?
Is generating API key.
Very nice. Once it's generated,
Yeah.
generation completed means it's generated.
Yeah, it's completed. Yeah, it's
Okay,
giving an option.
you can close it and say, I'm sorry, guys. Same kind of a project number you are getting might be.
Yeah, I got some number and
Project name, right? And API key also you might get here. This kind of API key.
Yeah, just got the API key.
Yeah, and that created option also you are getting here. See my screen first, and then you will get the understanding. See my screen. The same way you might getting all people after the creation of the API key, you have to create the API key. Once the API key is created, you have to close this window and you have to go and click on the API key. This is your API key, and don't share this API. Don't share this API key with anyone, guys. You have to create your own API key. Please take a note.
Yeah.
Okay, guys, because this is for personal and in my screen also, if you might send this API key after the session, I'm going to delete it. So that is not going to be useful. So for the practical purpose, I created and later I will delete it. The delete option is also, and again, I will create the new key. So you have to create your API key, guys.
Sir, now I'm able to see this option. Use Google Studio, Google AI Studio, try Gemini and build with the Gemini API, get API key.
So get API key, na?
Yeah.
See, is there anyone still facing difficulties to creating the API queue? Yeah, AI Studio. That's why first I type in this particular part, as if you remember it, I type only the AI Studio. That is in my Google. If you remember it, AI Studio only I type. So that is the only things you have to type it. Anyone still having any difficulties to creating Shabid, Upender, Kathy, Anita, Devanathan, Rohan, Senthil, Vimarsh, Ujjwal,
Yeah,
Venk,
I'm still struggling.
okay, Venkatesh Babu,
Sir, created, sir.
okay, great. Ayush, because see, if you people are not creating, not doing, so the prompt engineering you will not understand, guys. So if you need to understand the prompt engineering, you have to do along with me. That is the simple, because hands-on is required. Then only you people will understand. Jay Krishna, Siddharth, Suman Ghosh, Denzil Pinto, Jinesh, Mohammad Qayyum, Niyamat Ansari, Suresh, Pawak, Ramake, Rohit, Nilesh, Tanvi Mathur, Arjun, Srihari, Shankar Shahu. Sorry guys if I will miss anyone names because I go too fast.
No. I have managed to create.
Okay, great.
Sir, I'm able to download that API key. It shows up in some curl format. I mean,
No, don't take in a curl format. Why we are taking a curl format or something? Yeah, my screen is visible.
yes.
See, when you have to type on the Google search, you are getting a AI Studio.
Yeah, that's all. I'm done. I'm done with all that. Correct.
Okay, you are done now. You have API key, right?
API key in curl format is what?
But why you require a curl command or curl format? It's not mandatory the curl format. You can go to the Google AI Studio. Once you enter the Google AI Studio, you can see that Get API key. When you click on the Get API key, don't take this particular things. Don't take this download or something. This is a curl.
Right.
Okay. You have to click on the plus create API key.
Oh, okay. I missed that. My bad. Sorry.
So yeah, so you have to create API key, and from that you have to create API key. Once API key is created, you will see the options just like I'm seeing here. So when you click on this API key, you have to copy it. Just that's it.
I'm getting some errors, sir. It says failed to generate API key. Permission denied. Please try again.
Why it's like that?
Generating API key.
All people are getting. Why you are not
Ah,
getting?
now it has created.
Okay, that might be the glitch or network connectivity. Sometime it's also there. So API key is your LLM key, for example. Try to understand, guys. Okay. So without API key, you cannot able to use it. So please remember it. Okay.
Yep.
Clear for everyone, guys? Just give me the thumbs up.
Yes, I
Yeah.
am.
I have a
Yeah. Thank you.
question.
Thank you. Yeah. Who have a question?
So I have used the previously created project name, but do we have to create a new project if it
Not
is there? When
mandatory.
we are
No, not mandatory. If it is already project, you can take new, create just new API key based on that project. That is totally fine.
okay.
Okay.
Oh, can you show me one second? If you click the create API key, it's asking we have to select project name.
Project. Yeah. So you can select it if you already have the project.
Okay, if we are not, if we don't have any project, then do we have to create the project?
Yes. Okay.
Okay. Mhm.
Yep.
Okay. Thank you everyone for your response. I really enjoying the session for taking the session because I got the audience very attentive and very responsive. That's a good way. if we are going to conversations. Now I'm sharing the screen, my screen again. Okay. So just give me a minute. Where we are, where? Okay. So AI Studio, I got it. API key. So Grok is also one of the platforms. Later we'll see. We can use. This is also providing the free of cost. So that's why I'm not going to prefer OpenAI. ChatGPT I'm not going to prefer, because if I will use the ChatGPT, you have to pay some $20 a month. So if you are ready, you can use it. There is a Grok API key is also there. You can create it the same way you can create it API key by paying, but Gemini is giving you some 30 or 40 API keys free of cost, so that you can use it for practical implementation purposes. And I'm also sharing one of the notebook to all of you. Just give me a minute, okay? Uh, this is our notebook, and I expect all should follow this notebook. This is why I'm sharing, because anyone with this links, so this is, you will have the viewer access, because I'm not giving the editor access, because it might be it might happens like someone is going to be change anything, so I will get a problems while performing the operations. So don't mind it. Let me share in the chat so that all will able to see. So just you can see it, my this particular Colab. Already I installed in the Colab notebooks. You have to connect it first, guys. That first you have to connect it, and you have to install it. You have to install it as well. With this particular things, you have to install it. Okay. Please just go ahead one by one, guys. This is just a basic things I'm talking here. Definitely we'll discuss a lot of things later on about what exactly this importing command and everything. So we are using the generative AI, Gen AI model. So that's why we are importing. So you have to install this. So hope my Colab notebook is you all people are able to open, guys.
Yes, yes, sir. I see when I explore, when I expand this connect, I see different options. Which one do I need to select? I mean, connect to a
Different
host,
option.
connect to
Different
a,
option.
no. Connect to a hosted runtime, is it?
No. Don't connect for where you are in my notebook.
Yes, yes.
No. Don't connect or something. You have to just view it.
Oh,
Don't do anything on my notebook, guys. My notebook is just a reference for everyone.
okay.
Okay, just a reference for everyone for the installation, because see, this some installations is required to do directly, just copy and paste. We are learning to the prompt engineering, so we will understand the prompt engineering concept, because if I will write and you have to see and write this particular things, it will take a lot of times. So that's why I just given you have to import some of the initial things only. Okay. Am I clear with everyone, guys?
So the link that you gave, that got open, and there is this this pip command. Do we have to click on it, or we copy that and open up?
Copy and paste in your notebook,
Okay,
the,
okay,
the
yeah, yeah,
notebook which you created.
okay, okay.
Okay. So you all should prepare one notebook, because as you know that there is a mini project or something, I will take those notebook as well as the reference. So that's why actually I just want to make sure all of you guys. Also, if you might seen about in the AI studio, when you enter in the AI studio, there is a Gemini models. Gemini 2.5 model is there, 2.5 Pro, 2.5 Flash, 2.5 Flash Lite. This is 2.0. This is Flash Preview Image Generation Hot model. 2.0 flashlight. This is a gamma model. You can see that this is specially defined for the medical purpose. Okay, guys. And the other models are also there, LM 2.0 flash. So with the help of that API key, you can use any of these models. So I'm using 2.0 flash here. Okay, I'm going to use 2.0 flash, not going to use any other models, because Gemini 2.0 flash, 2.5 flash having a 2.5 flash or 2.0 flash model I'm going to take. 2.5 pro I'm not going to use because it will what I can say that end very soon, because whatever the tokens you will get, it will lose, because their charges are very high. The free of cost it is there, but yeah, obviously free of cost, but it's 1 million context window. So once 1 million context is going to be elaborated tokens, so that models is not going to be comes in a picture. So that's why, because its cost is very high. So I you can copy this particular thing, Gemini 2.0 flash, go to your code, and whatever things you can see that API key I passed. This is my API key. Don't copy, guys, my API key, because I will delete it later. It will not work, because everyone we can use it, and you can use it. I'm using Gemini 2.0 flash. Just how we can minimize the task. And I pass one prompt as well. If you look at this, I pass one prompt, generate content, like how many planets are there in the solar system, basically how many planets are there in the solar system. So when I pass this prompt, basically, okay, when I pass this prompt, okay, let's have to run this particular things first, because if the things are not going to be installed already, this is installed in my system. So first time you need to install it. Whenever you have to start using, I already started using, so already I installed, and then I will run this particular thing. So let's see whether it's we are getting the output or not. See to it that. So there are 8 planets in the solar system. I'm just showing some context here. Just try to use it, guys. Okay. This is which model I use, guys? 2.0 flash. If I'm going to change it, 2.5, okay, from 2.0 to 2.5, and if I again run this particular part, you can see that the answers are might be in more details. If you might see my screen, guys, hopefully you are getting the response, or you are observing the response, like model generative AI is a Gen AI, configurations, API key, Gemini 2 flash. I just pass. You can pass any prompt, okay, in between this particular things. No required to use coding or hard coding, guys. Here you can pass any prompt in between the parentheses. So please remember it. Those who are not technical, you have to just ask any questions and just click on that, you will get it prompt. So just like in this Gemini, we are using the same things we are passing to our this Colab notebook as well. Got my point, guys? No need to write or no need to speak. You can just give me the thumbs up. I can see the thumbs up if you people are able to see and able to understand. Okay, thanks. We have only 15 minutes left, so not to worry. We have to go step by step. Each and every participant should understand that is my main motive. Hope in your notebook also the things are working fine, guys. Or if anyone's still facing a difficulties.
Sir, I'm able to get the output. Just wanted to understand the model. Gemini 2.0 versus 2.5. What is the difference, please?
It's a difference of the training parameters. The 2.5 model is more advanced, trained on a more billion parameters, more instructed parameters it trained, and 2.0 was old and it's going to be deprecated in the month of November or December somewhere. So it's come to it was an old model, 2-year-old model, And 2.5 Flash is just released from June only. 2.5. So it's a latest model, more upgraded model provided by the Gemini. So that's why the answers are more in detail, more in line, because more less instructions we passed. If you can see to it here, guys, only I ask about how many planets are there in the solar system, right? If I'm not wrong. So the Gemini is giving 2.0 is giving about what I can say, that 8. Earlier answer was 8, if you remember it, guys. And that was the answer, as this was the only answer. And that answer is also correct. That is not a wrong. But Gemini 2.5 Flash is giving me about more contextual answer or more in-depth answer. Like there are 8, and these are the Mercury, Venus, and the Neptune. Pluto was recognized as a dwarf planet in 26 by the international about this particular things. Okay. Now, yeah. Now coming to one topic here that I was mentioned, like I will explain context window. Uh, we have to try to that context window as well, because that is also important to understand. So let's
I have a question here.
yes, please go ahead.
Yeah, so whatever thing I have done so far, I think I could have done the same thing by giving that prompt to, like, let's say to ChatGPT or Gemini as well. I mean, there also I will be getting the same response, isn't it?
Yes, it might be.
So
You will,
why we need keys and other things?
yeah, without key, how can you use in your environment? If you need require to use that LLM model in your productions or in your practical or in your
Okay, okay.
applications,
All
so
right, all right.
how you are going to
This
integrate? So
Means
this is like
consuming the
creating our own environment, and we are trying to get the result.
consuming the same output
Exactly.
somewhere
Yeah.
here in the application. Okay.
yes, so
All
that API way only you can integrate, right? Or there
okay.
is a multiple way we can integrate, just like in Vertex AI Google. We can integrate with Vertex AI directly. With the API where we can integrate with the help of Hugging Face. So or we can download that LLM models and we can use those LLM models as well. But downloading and everything will be the costly. We have to maintain such a high regularized machines and everything. So that particular things we have to maintain. But API key is something like a key. You whenever in whichever applications you need to use, you have to just pass the API key and you have to just pass the command, and that particular LLM models will provide you the response.
Okay. One more thing. Since we are querying or we are prompting the model, which has knowledge or which has I mean, which is providing output as a journal, right? But let's say if I'm working in any organization, right? So definitely I might be using that particular thing for my organization data, right? So how that particular thing will work in that case? I mean,
Fine
that
tuning. You
model.
have to you have to either store that entire data into the LLM, and or you have to do the fine tuning with that respective data with your LLM models, or you can do the RAG. So
So so that
these are
means
the way,
yeah. Please go ahead. Please go ahead.
so these are the way you can utilize your own data. Based on your own data, LLM will going to top up the response.
Okay, so you mean you're saying like we have to create our own LLM model within an
No,
organization?
no. The LLM model would be the like Gemini, ChatGPT, any LLM models.
Hmm.
But on that LLM models, you have to train those LLM models on your data set or on your company data.
Yeah, but why any company will give data to public model? I mean, that Gemini or ChatGPT or
there,
any
there
any.
are there are for example,
Mhm.
there are a lot of educations institute, not Gemini or something like that. I'm talking Gemini or something like that. For example, there are a lot of, because I did a project. For example, see, so not all data they are giving. For example, we have a physics, chemistry, and maths books there.
But I think we need some more good way we should get the response. Currently, whatever the response we are getting from the Gemini, if we passing any questions, we are getting the response which are not as like school teachers are giving. But we want to build the LLM, or we want to train the LLM models just like how we are delivering the lectures or the practicals to the students. So in that scenario, you have to first create your data, and you have to feed those data to LLM, and that LLM would be the secure, and that LLM is not going to be used by any other person, because that LLM you have to download it in your you can say that system or in your machine. That LLM would be not like Gemini is going to be live and anyone from the world is going to be used. Did you understand my point? What exactly? Just like if I want to do the fine tuning, first I have to download those LLM models in my system. And in my system, whether it's a virtual system or whether it's a physical system, I have to download those LLM models in my system, and I have to train those LLM train with my custom data, and then I can use those LLM models with more, I can say that, precise way or more filterized way. And that LLM models is not going to be shared with the Gemini or the ChatGPT or anyone.
Okay, okay. So that is also possible. Like I can have my own LLM model within an organization, which is completely private.
Mhm. So that's why Gemini is there, but it's a private. It's not an open source Gemini, just like we are using right now. And they have obviously about the security and everything we can maintain about that particular things. So it should not like, because that LLM you downloaded in your virtual machines and you trained it, and that LLM is going to be used by yourself only, because once you train those LLM models on your custom data set, then again you have to deploy those LLM models. And that
Okay.
LLM models you deployed, you can use those LLM models with your API key only. And that
Okay.
API key, if you share with anyone, anyone can use. If you not share with anyone, no one is going to be used. And that deployed model is going to be on your system only. It's not on Google or OpenAI or anywhere else.
Okay. Okay. So the prompt that we have given in this particular example is something which is giving me the output from as a text, right? Uh, Behind the scene, maybe some text searching or the model which you explained earlier, that is working, right?
Yes,
But
yes.
generally in the organization,
Mhm.
the data is available as a tables, right? Tables
Mhm.
or like that, right?
Mhm.
So is it possible to feed table data also in the
Yes,
model?
yes, yes, yes. We'll see
Okay,
in
okay, okay,
upcoming session. Don't worry. Like,
okay, okay. All
we'll
right.
definitely cover those particular things as well, guys.
All right. Thank you, sir. Thank you very much.
Yeah, not to worry. So because this is just initiated, because from tomorrow, not tomorrow, right? I think Sunday we have the next session. So from Sunday session onwards, completely hands-on things are going on, not about the theory or something like that, because I also not believe in theory or something. Now I want to just highlight and complete these two things, and then we'll wind up this session, guys. uh, so just give me a minute. Where is my, yeah. So the question, not question, basically the topic is what is context window in LLM, like 1 million or something, or 1100K or something. So we have to understand the context window is basically large language models is refers to the maximum number of tokens the model can see or consider at once during a single input output session. Okay, now everyone again come to the API. Sorry, not API. That AI Studio. AI Studio. You can see to it that you can see here about like the token count. If you everyone can see here the token count on my screen. Token count. How much it is? 1 million.
10 lakh. No, hold on.
Yeah, 1
10
million.
lakh 48,500
Yes, 1
something.
million.
1 million. Correct.
Yeah.
Yeah,
So
1 million.
Yeah, so Gemini 2.0, 2.5 having the 1 million context window. 1 million context window means what? This is my suppose content. If I will copy and control C, and if I will go ahead in this particular things, and if I will paste it here, now see that here I will see that the token count. How many token counts I am using as an input?
70,000.
1782, right? So
1,000.
1782. So 1 million context or context window means something like, if I'm saying 1 million context window, so input and output, this model have the capacity from input as well as output. He can provide the 1 million context kind of tokens. Like if input is like 70,000 or 55 0.5 million, and output is also coming in a 0.5 million, that kind of a context window this model have. Tokens, what exactly? That's already I mentioned about the tokens in the chunks, like if any words are there, something like so that is going to be converted into the number of tokens. That's already I explained while explaining the transformer. So hope everyone remember it, that tokens or something. If you remember it, something like if I will delete it here, if I will write hi, so let's see how many tokens it's considering to. My name is Khan, for example. Now, how many tokens it will consider? 6 only. Did you got my points, guys, here?
Yes, clear.
Yes. Yes, sir.
So, yeah, so you can see to it that tokens. So hope everyone clear about here this particular idea about like what is about like this context window means this is a 1 million context window. Gemini is having 1 million context windows, some having 100 1000 context windows. So it's a different context they have. Okay, so just remember it, and it's matter most. LLM does not do not truly remember your full conversation history unless it fits inside their context window. Once that limit is crossed, earlier parts of the conversations are dropped. So that's why if you remember, someone was asked question like agentic AI and something like that. So it totally work on the context, this particular things. So that's why at that time I told like I'm not going to give the answer correctly here. So, but agentic AI will remember that particular things. But your LLM models or this generative AI models are not remembering, because if 1 million or 10,000 context window is going to be passed and you pass new prompts, so the previous one, the LLM is going to be hallucinated and you will not get that kind of a history or something like that particular things. One token is equal to something like 3 by 4 of a word in English. So if I'm taking like a 1 million tokens, so it means like 75,000 words, like an entire novel or something like that. So just on an average I'm giving, guys, huh? So just don't take it like 100% accurate, on an average or approximately kind of a things. GPT 3.5 having 4096 tokens. GPT-4 is having early 8192 tokens. GPT-4 Turbo is having 128 thousand tokens. Claude 2.1 is having 2 lakh tokens something. 1 Pro is 1 million. Mistral is having 32,000. Llama is having 4K to 32K tokens. So this is having the different context window, guys. Now coming to this particular part, that is a temperature. That's already in my notebook. If you guys might seen here about, uh, that's already I passed the comment as well. So set models parameters here about this particular things. If you might see my set models parameters here, uh, here what exactly it is, and definitely we'll see in the upcoming sessions like how they are working. Right now we did not have enough time to see the responses, how it's going to be covered. And even in AI Studio also you are getting something like that. You can see that temperature, if you can see that model low, medium, high, something temperature is something like, you can see to it here in AI Studio. So you can get the experience from here. But temperature, top K, top P, top K, max output tokens. Now maximum output tokens I am getting only 8192. Okay, and I written about one token is considered as approximately 4 characters. Okay, so here I use like configuration temperature. First of all, what is a temperature? Temperature is like, purpose is like controls the randomness or the creativity of the outputs. Like range is 0 to 2, Okay, its range is between 0 to 2, sometimes 0 to 1. So randomness in output token selection basically. So whenever you have to keep the value lower, like 0.1s, so more focus deterministic output you will get, or safe repetitive. And if you are keeping the higher values like 0.9, 1.2, so more creative varied output. Really, it's control the randomness creativity of the output. Hope everyone clear about this particular things. Like we'll see in the next example, because right now we did not have already we have this particular things. If I will search it with the minimizing about this, I will get the response, but later I will explain in the next sessions as well. Now the next one is a top P. Top P is basically purpose is nucleus sampling, that is called as. Those who are looking the job or something working in the prompt engineering, these are the very frequent questions are asked. Nucleus sampling, because prompt engineering is totally based on this particular factors as well. Nucleus sampling controls how many tokens are considered by probability mass. Probability mass. So range is like it's 0 to 1. The models looks at the top tokens whose combined probabilities add up to top P. Lower top P, more conservative, higher, more creative. So you have to always keep low value about this particular things, because if you put the higher, it will get a more creative, and more conservative if required, you have to keep at the low. So for example, if you keep as 0.9 or 1, only consider top tokens that together add up to 90% total probability. And if you are keeping one, just like I keep here, so consider all possible tokens, no filtering would be there. So this help filter out unlikely tokens even if their probability is not 0. Now this is top K32. That's range 1 to infinite token selection window basically. So it's limit the model to only the top K most likely tokens when picking the next word. Like range 1 to any numbers, commonly 10, 20, 40, any, just like 32 I kept. So top K is equal to 1 is like always pick the most probable next tokens, deterministic basically. Top K32, it's randomly picked from 32 most likely tokens. So that example we will see in the upcoming sessions. So if the model predict 100 tokens as next possible words, so top K32 only consider the top 32 tokens based on the likelihood. That likelihood theorem, it's a mathematical concept is there. Uh, so it helps balance randomness and relevance. Uh, or instead, so we have in the next sessions when we are going to meet, we have to change and we have to see the response as well, and then you will get the better understanding. And the last one is a max output tokens, that 8192. It's defined the maximum number of tokens the model can generate in the response. If you hit this limit, model stops output. Even if the task is incomplete, it will stop. Helps control response length and prevent runaway outputs. One token, that's already I told, 1 to 3 to 4 characters in English, and max token output is what 8192. That means roughly 6,000 words max. So is used to limit cost, control latency, and avoid memory overuse as well. So we can control this particular things with this particular things, how they work together. These parameters work together to balance. Like creativity is for poetry, storytelling, brainstorming, precision for coding, technical answer, and summaries. Example scenario is like, want creative blog ideas, you have to keep temperature 1, top P is 0.95, top K would be 50. Want precise code output, you have to keep temperature 0.2, top P 0.8, top K 10. And this is the way actually you will get that particular understanding and the response. So this is super important, guys, if you might use somewhere. And I always suggest, if you're using this kind of a things, you have to use in this particular way, and definitely you will get a better understanding and a better way to utilize of this LLM models for your own purpose. So you will get all these particular things, and you can stop sequence, and a lot of things you can add it here. So hope you guys enjoyed today's sessions. Anyone having any questions, queries? I already run 5 minutes. I gave ahead here, but yeah, that already I requested you guys, so it will take more time to complete this. But yeah, I will try to pop up this particular things in a precise time. But sorry if it will take 1 or 2 days more. So forgive me about that particular things. Anyone want to say something? How was the sessions? Uh, that would be yeah, definitely you will get all the things, and even you will get more materials from my side as well. Yeah, anyone want to say something? Anything you have not understand, whatever I try to elaborate in today's sessions? How you enjoyed sessions? Can you just go ahead and just give a feedback? The feedback is always important for LLM models, similarly important for me as well, to improve myself as well, guys. Go ahead, please.
So for this LLM model, next day, I would like to go again in this AI lab. This is one, and I would request you to suggest one introductory book on this.
Yeah,
I mean,
definitely I will suggest. Yeah, Suman, I will definitely. Yeah, anyone more, guys? Malik, Amit, anyone? Not about anything.
Please put the syllabus in the group.
I think you might have in the chat, but if not, I will put it.
The
Not to worry.
PDF that you showed early on, please put
Okay,
that in.
okay, okay, okay. I will ask team to put. Oh, sorry, Sri Harish Shankar Sahu. Sorry. You can go to the. You have 1 day. Just go ahead, do it, and let me know in the upcoming sessions. Definitely, we will try to catch those particular things. Anyone more want to say anything? Want to add something? Kathy, hope you understand. Hope you enjoyed the sessions as well.
Yes, sir, I did. Thank you so much.
Yeah. What about others, guys? Tanvi, Arjun, Nilesh, Ramake, Pawak, Suresh. I'm not much into the technical. I taken in a layman way, try to elaborate about this particular things. Muhammad Kayyum. Okay, thank you, guys. Uh, uh, definitely will meet in the
Thank you very
upcoming
much. The
sessions.
pace is really smooth. It was excellent. Thank you.
Okay, thank you so much.
Thank you, sir. Yeah.
Thank you.
Thank you.
Yeah, sure.
Thank you, sir.
Thank you, guys. Have a nice
Thank
day.
you.
Nice
Thank you.
evening.